Hi everyone, welcome back to the channel. So today we will be starting with another topic which is heaps from our SD sheet. I'll just show you the problem statement which is heap sort. So we are starting with this heap sort, and actually this heap sort question itself will include very good foundation which you need to know for heaps, starting with heaps. So let's start with it. Okay, let me take this example. 4, 1, 3 and 9, 7. So what is given here? The question is simple, that you are given an array and you have to return the sorted form of this array, but by using heap sort. Now what is heap sort? So before that, let's understand what is a heap. Basically we have two kinds of heap, max heap and min heap. So the property of heap is that you just need to know two important things. That first of all, a heap is a tree like data structure, right? Binary tree like data structure, and the tree is of this form. Let me tell you, for example, I am taking this tree, right? 4, 5, this is also one tree. 1, 2, 3, 4, this is also one tree. Right now none of them is heap. Let me take a valid example. For example, 5, 1, 4, 2, 1. Okay, and let's say, okay, so focus over this tree. This tree is actually a heap. Why am I saying so? And that too a max heap. And if I make a slight change in this tree, if I make a tree like this, 4, 2, 1, 3, it will no longer be a max heap or any kind of a heap. Reason being, so the two major properties are that if I'm talking about, you can take any one throughout this discussion of heap. We can choose any one, either max heap or min heap. Let's go by max heap. So the property is that you will always have the maximum element of all the elements that you have, right, at the top of your tree, right? This is the root of the tree, will be the maximum element always, correct? And as you can see, out of all the elements, 5 is the maximum element. Second important thing is that the root level nodes are filled in such a way that you first fill up all the left side nodes. That means there shouldn't be any gap while you are filling the last level of the tree. The tree should be in this way that you complete the left nodes and then you move to the right. So this property has to be maintained. Okay, now how is heap represented? Although it's a binary tree like structure, but we represent it using an array. Now let's come back to our question, what we want to do. So this is some property that you need to know beforehand for a heap. Coming back to the problem, so we have this array and I want to convert it to the sorted form. That is as simple as 1, 3, 4, 7, 9, right? So you'll say use arrays dot sort, simple thing. No, but the intent here is that we want to understand what is a heap sort. So let's see, let's understand first how will we convert it to a heap, and from there we will understand how heap sort will take place. So first of all, this is an array and I want to convert it into a heap. So I have to take care of this thing, that my maximum element is always at the top of my tree, correct? Okay, how can we do that? So have a look. If suppose I visualize this array as a tree like structure, so you will see that I have 4, 1, 3, 9, 7, right? And in this case, if you have a look at the indexes of this array, so this index has left child at index 1 and a right child at index 2. Just visualize it in a tree like structure. So its left child is here, right child is here. If I talk about 1, one's left child is 9, whose index is 3. Why I am saying to you to map the indexes? Because see, we will find a relation which will help us in building the heap out of it. So if you check that if my parent is present at I index, my left child will be at 2i and right child will be at 2i plus 1. So either you can do it this way. Okay, so if your I is 0, right, your left child will be present at index 1 and right child will be present, put 0 in place of I. So your right child will be at index 2. So for 4, you have right child 1 and left child 1 and right child as 3. You can map the indexes. If I want to know where are the left and right child of 3, I'll just check the left index where ideally its left child should be. So that will be 2i plus 1, that is 2 into 2 plus 1, 5, index 5, and the right child should be at index 6. So for parent index 2, but you see that our array itself is of size 5. So the last index that I have is 4. Ideally, if the size was bigger, I would have found its left and right child at index 5 and 6, but right now it is index out of bounds, so I don't have. So this is simple relation that you need to know, by which you can find left and right child. Okay, second thing. Now let's start building heap out of it. I want you to observe this tree and start building heap from bottom to upwards motion. Okay. So for that, I will start my iteration. If I start my building heap process from the last level, you know that all the leaf nodes will, if I have only one node as my tree in my tree, or I just have only one node, it will be a heap in itself, right? Right now, if I talk about the leaf level nodes, they are in itself, they are a heap because they do not have any further tree below them. So if I just consider this as a separate tree or this as a separate tree, one node in itself will be a heap, correct? Okay. So there is no use if I try to call my heapify function for the leaf level nodes. Let's do this process from the level just above my leaf level node. Let me write it properly now. You should see that right now my tree is not a heap, right? It's not a heap. So let me make my tree here 4. Why it's not a heap? Because you see that also this heap property should satisfy for every node. It's not like the root level node, the topmost node should be a heap. This property should follow for every subtree. If this is a subtree, for example 1, 9 and 7, do you see this subtree holding the property of a heap? No. If it were a heap, the largest element out of all these 3 elements, which is 9, should have been at the top of this tree, right? So I hope you understood the point. Okay, let's start now this is what we are going to do. We are going to create a heap from here. How are we going to do? Let's start from this level. Okay, so I will just check what are its left child and right child. Left is this, right is this. And you know how you can find a left child and a right child, correct? Okay, so you will compare which is the greater one out of these 2 nodes. 9 is greater. Then the greater one, the greater of left child and right child, you compare that with your root, current root is 1. If that value, the greater value is greater than your root, that means it needs to be swapped, because I am looking forward to make it a max heap. So every subtree should follow this property. So 9 should take place of 1. So if my 9 goes here and 1 comes here, I have to make sure that 1 now further, if for example it had further nodes below it, it should satisfy the property of heap. So I will again make a call for a heapify function of heapify for this particular node. But right now we do not have any further nodes, so there will be no such calls taking place. Okay, now I am at this index. I started from this index. Actually I should have started this from here, and then I will go like this, because in your array it will look like this. I am ignoring the leaf level nodes, which is 9, 7, so I am directly starting from 3. And since 3 did not have any further nodes, I did not show you the heapify, applying heapify here. I started from here, although we will ideally be starting from here. Okay, if I make a call of heapify for 3, nothing is going to take place because there are no nodes further below 3. Okay, for 9 I have done. Now if you see 9, 1 and 7, this subtree is making a heap, right? Because the maximum element is present right here, which at the top of this tree. Now moving ahead, my index, I will move to the next one, which is this. So right now what has happened, I was at 3, this 9, I was already at 1. Okay, 1 got swapped with 9, so here I have 9 now, and here I have 1. So my array is looking like this right now. So I have done this task for this index. Now I'll move backwards. I'll be at 4. Now I'll do the same thing for 4. Check its left child. Left child is 9, right child is 3. Which is the greater of 2? 9. I compare this with the root which my current index is at, my I is at this index, so I'll check for it. So 9 is greater than 4 and I want the maximum element to be at the top of my tree, right? So 9 will come here, I'll swap it, 9 will come here, 4 will go here. But if 4 comes here, it might impact the subtree that 4 is part of. Now 4 is part of this subtree, so I have to make sure that this still follows the property of heap. So I'll again make a call to heapify function. So basically it's a recursive function which is making calls whenever we are making a swap, and swap is taking place whenever you are finding a greater element in your left or your right child, you swap yourself with it. So now finally if I make a heapify function for this subtree 4, 1 and 7, you'll see that 7 is greater, so I'll swap 7 with 4. So finally 7 and 4. So finally this tree is looking like this: 9, 7, 3, 1 and 4. So in array this is, the array has been modified to this array. Now finally your array looks like this: 7, 3, 1 and 4. Okay, so one part is done. What was that? Heapify part is done. Now you will see for every subtree you are following the property of a heap, and the maximum elements of all the elements is present at 0th index of your array, which is the main root of the tree. Got this point? So we have achieved two things. First thing is that maximum element is now the root, max element is root now. Okay. Second thing is, if you check, every subtree is going to satisfy the property of a heap, that is, you have created the heap of the array that was given to you originally. Correct? Okay. But next step is that it is not yet sorted. So I have to convert this heap to a sorted array. So how am I going to do that? So that is very simple. Since I have converted this to a heap, now I will make use of the property of that heap. The property is that the max element is always present at 0th index of the array. So by making use of this property, I am going to convert it to a sorted array. How am I going to do that? So since you know, your heapify function will take care of the fact that your max element is present at the 0th index. So you will get the maximum from here, and in a sorted array, the maximum should go in the end of your array. So I will swap 0th index element with your ith index element, which I am starting from the end of your array. Please understand this thing. So I am starting this I from the end of my array and make a swap. So when I make a swap, 4 will come here, 9 will come here. Now you know the ith part till the end of your array will be a sorted array. So you have to bring your I to the previous index and make sure that now this portion, that is from 0 to I, should be following the property of heap, so that now I get the second largest element. Actually, ideally the largest of all these elements from 0 to I, but in the entire array it will be the second largest element. So first thing is, in order to convert it to heap, you build. Now let me write the step from the beginning. Initial array was given to you. You make a function call which will be building heap to your original array. Now I have the array already in heapify form, right? I have this heap with me. Now what are you doing? You are always swapping, that is swapping your 0th index with ith index, in which there is a loop which starts from last index and goes until your index 1. Why that? Also you will index 0. Now when you swap, the third thing within this function, means within this part, would be that since you are swapping and you are bringing the largest element at the end, but this portion needs to be converted to heap again. So again you call heapify function for what all elements from 0 till new I, which is basically I minus 1. Just showing you for representation purpose that if I was here, now you're making a heapify call for 0 to till I minus 1th index. So this array, this portion of array will be converted to heap. So if you visualize it, now this is looking like this: 4, 7, 3 and 1. I want to call heapify on this function. So How is it going to take place? You know, heapify function starts from one level above the root level node. So I'll check for 3, it's already a heap. Now I'll check for 7. I'll see that there are no nodes greater than 7 in its left and right child, so it's already a heap. Now I'm at this index. I'll see 7 is greater than 8, so I will swap 7 and 4 will come here. This is, I am iterating, means I am recursively making call to heapify. So when 4 comes here, my heapify function will be called for 4, and I will see that it is finally in the right heap form. So what change came here? This array will be modified such that now this is your 0th index is containing what? 7, right? I have 7 here. Index 1 is now 4, correct? Index 1 is now 4. Let me write it. And index 2 is 3, index 3 is 1. Now again you are doing the same thing, that you are swapping your 0th index element with ith index. So I right now was at this position, so this 7 will come here and 1 will go here. Move your I to the previous index, repeat this process. Now you have 1 4 3 in your array. Call heapify. So I see 4 is greater than this, so I'll swap 4 with 1, make a call. Now nothing more will happen. So what your heapify function will do? Heapify function will make this as 4, this will be 1, and this is 3. Now you have the largest element 0th index and your I was at this position, right? So you swap this 4 with this 3. So finally this 3 will come here and 4 will go there. So this 3 comes here, 4 comes here. So you see, we are actually sorting our array until for this n minus 1th index, this is sorted 4 7 9. Now the only portion left is this portion. So you have 3 and you have 1. So your array is actually like this. I make a call, heapify function call to this array, remaining part of your array. So heapify will be swapping this 1 with 3, and that's what you have now. So 1 will come here, 1 comes here, 3 goes here. So you have 1 here and 3 here, correct? Okay, sorry, I made a mistake. What was it? So you already had 3 and 1, and when you call a heapify function, you see there will be no change because you already have the max element at the top. So what next step is, you swap 0th index with ith index. I is right now here, so your 3 will come here and 1 will go here. 1 comes here. Is there any need to call heapify for this portion now? No, just for one element there is no need. And now you see we have actually found the sorted array, and that's all about this heap sort. You have sorted this array 1 3 4 7 9. Now let me come back to that point where I told you that we start from one level above the root level node. Let me show you this portion. So why we do that? Because you know there is no point of calling heapify function for the leaf level nodes, and in a tree like this, binary tree, you will see that you have around n by 2 nodes itself in the root level node. So in an array, actually n by 2th index or n by 2 minus 1th index that you can check will be actually pointing to this node. So we can easily make this decision, and the right index, we can choose the right index, which is I'll be starting from I equal to n by 2th index, and my I will go till 0th index, and that's how I am going to do, right? So let's have a look at the code so that you can relate whatever we discussed. See guys, there are 3 important parts here. As you can see, this was the heap sort function I wanted to complete. So first thing first, I will build my heap, right? This is the original array. Once I build the heap, the array that I will get will be this array. So from 4 whatever it was, actually we have already modified the array. I can't show you what array I will get after creating a heap, but yeah, I think this was the array that we got 9 7 3 1 4 probably. Yeah, so build heap function task is to convert this array to heap. And how we are converting? We are starting from exactly n by 2 minus 1th index, which will ideally be pointing to the last node of the level above your leaf level and goes till I greater than equal to 0. And for each node I am making a call to heapify function. Heapify's task is to make sure that every subtree in itself is a heap, that is the maximum element should be at the top. That's what we are doing. My largest is pointing to that root node, parent node at which I am present. Left is pointing to 2i plus 1, right is pointing to 2i plus 2. In these two steps we are checking that which element out of left child and right child is greater, and is that greater element, is it greater than your parent node which is present at ith index. If that is the case, I swap it, right? I swap that element. This is simply by using you know how we swap the elements by using third variable. That's what we have done. And once we have swapped the element, I have to make sure that the element which got swapped now in its one of the left or right child, which was a smaller one, I have to make a function heapify call again for that remaining subtree. Getting it? So here are n and largest, that is the element which got swapped in the subtree. So you will be able to understand if you just do a dry run, right? I have already explained you these things, just trying to map it with the code that we have here, right? So this is your heapify function. And finally, once you have got, so this is how build heap function itself is calling your heapify function. Heapify function itself is a recursive function. So these are some interrelations that I've already discussed, and in first time it might be a little confusing, but I'm sure if you try to do one by one, step by step, just then you will understand. Okay, so build heap functions task is done. We got a heap, and from last index now I am just making sure that I swap the 0th index element with ith index element and just call heapify for the remaining part of my array which I just showed you, right? So that is all about this question. I hope you all understood. So if you have any doubts, you can ask me. Fine? We are done with it. Since code and steps are lengthy, but trust me, just go with the flow of how I've explained you. You will understand each and every function. Okay? So that's all for today, everyone. If you have no doubts, I'll just wrap it up. Okay? Fine then. Thank you, everyone, and see you all in the next lecture. Bye bye and take care.